Here we're asked to solve a linear system by graphing. We'll begin by finding an equivalent system where the two lines are written in slope-intercept form. Let's begin with equation 1. Negative x plus y equals 6. We can solve for y here if we add x to both sides. That leaves us with y equals x plus 6. So we'll write that in for our first equation. Next, let's do the same thing and solve for y on the second equation. In this case, we have 5x plus 2y equals negative 2. Here we will subtract 5x on both sides. That leaves us with 2y equals negative 5x minus 2. Dividing by 2, we have to take care to divide both of these terms by 2. And that leaves us with slope-intercept form. Y equals negative 5 halves x minus 1. And so we can write that in for the second equation. Now that we have an equivalent system where both the lines are written in slope-intercept form, we can graph them up and try to determine the point where they intersect. Now when graphing these, we have to take care because accuracy becomes really important. Let's begin with a rectangular coordinate plane. Okay, here the first line has a y-intercept at 0, 6. Now the slope here is 1, or we can rise 1 and run 1. Certainly we can rise another one and run again 1. So here we can graph the first linear function. Now the second line has a y-intercept at 0, negative 1. And in this case the slope is negative 5 halves, so we'll rise negative 5 units and run 2 units. And then we can graph that line. Now from my graph, the solution here, the point of intersection, appears to be negative 2, 4. Now we should check that. Let's substitute those values into the original system and see that it satisfies both equations. And so here we'll substitute negative 2 in for x and 4 in for y. Simplifying, we're left with 2 plus 4, and certainly that does equal 6. Now let's check that it satisfies the second equation. And so here again we'll substitute negative 2 in for x and 4 in for y. That'll leave us with negative 10 plus 8, and sure enough that does equal negative 2. So the solution here is indeed negative 2, 4. And that is the simultaneous solution.